Hello everyone. Today's topic is reflexive relation. In my previous videos, I already explained about identity relation, universal relation and null relation. So let us proceed further with the next type, that is reflexive relation. Now what reflexive relation means? In reflexive relation, a relation R in a set A is said to be reflexive if and only if. This stands for if and only if. For all A belonging to A must belongs to R. Now what it's mean, bete? We already discussed about this concept in identity relation also. Same for the reflexive relation, that if I take the set A containing two elements, suppose 1, 2, then what reflexive relation means? In this type of relation, for 1 belongs to A, 1 must belongs to R. For 2 belongs to A, 2 must belongs to R, right? So what reflexive relation means? In reflexive relation, for a set A containing two elements 1 and 2, the relation will contain 1 and 2, right? But you already know that this you can say that identity relation also, because in identity relation we did the same thing, that every element is related to itself, right? But if you remember, there we wrote that every element is related to itself but only to itself, right? So what reflexive relation tells about, every element must relate to itself, but it can be related to other elements also. So suppose if I have taken the another set R2, right? The another set R2, then if I say that there are three ordered pairs, 1, 1, 2, 2, and suppose 1, 2, right? So can you say that this is reflexive? Yes, it certainly say that it is reflexive. Why? Because it fulfills the given condition that for all A belonging to A must belongs to R, right? A must belongs to R, but it doesn't mean that it can never take any other ordered pair, right? It means 1 must related with 1, 2 must related with 2, but 1 can relate with 2 also. So this can also be reflexive relation. So is this reflexive? Yes, this is a reflexive relation. Why it is so? Because for all A belonging to A must belongs to R, right? But it doesn't mean that it can never relate to any other. But is it an identity relation? No, it is not an identity relation, because in identity relation what we did, that every element is related to itself and only to itself, right? So this you must focus on, that for reflexive relation, all numbers should be related to itself, but it can relate to other numbers also. But in identity relation what we did, that all numbers are related to itself and only to itself. So what it's mean, bete, that you may put note here, that every identity relation is reflexive. Every identity relation is reflexive, but reflexive relation need not to be an identity relation. So I hope the idea is clear, that for reflexive relation, the necessary and the sufficient condition is that every element must relate to itself, but it may relate to others also. But for identity relation, every element is related to itself and only to itself, right? So what type of mathematical examples can be there? Let us proceed with those examples. So in mathematics, what type of questions they may ask you, that for a set containing three elements, suppose the set A containing three elements 1, 2, 3, right? The relation in the elements of A and B is such that A is less than B, right? A is less than B. Then is it a reflexive relation? In your exams, in your textbooks, they may ask this type of questions, that prove that it is, find out it is reflexive or not reflexive, right? So what we should say there, that for reflexive relation you must connect each and every element to itself, right? So how you will read this relation, that for reflexive relation you have to check that can you say that A is less than A, right? Because the relation gives you the statement that the relation between the two elements of the set A is A less than B, right? For reflexive relation, what we will check? For reflexive relation, can you say for all A belonging to A must belongs to R, that is A is less than A? Can you say? No. Certainly no. Why? Because the number can never be less than to itself, right? So for reflexive relation, you must relate a number to itself according to the relation given, right? Here the relation given is A less than B. So what you want to check, whether you can say A is less than A. So certainly you may say no. So what it's mean, that this relation is not reflexive, right? But if I give you another relation, suppose this is relation R1, and if I give you another statement that AB such that A less than equal to B, so can you say this relation is reflexive? Certainly yes. How? Because for all A belonging to A can be less than or equal to A. What they put here, they put A less than or equal to. If it satisfies one of the condition, then also we may say that the relation is reflexive. So what it means, that if there is a sign of equality, then you may say the relation is reflexive, but you cannot say for the number that a number is less than to itself, right? It can never be. So it will not be reflexive ever, but this type of relation in which they put the sign of A less than equal to B will always be reflexive. Similar result for A greater than equal to B also, because a number can never be greater than B, but yes, it can be equal to B, right? So for this reason, this will be reflexive. Similar result for less than also, and similar for greater than also. So whenever you want to give the example of such type of relation which is not reflexive, right? So you may consider this type of example there, that the relation A less than B will never be reflexive for all AB belongings to the set A, right? And to prove, to give the example of a reflexive function, you may quote this type of example there, that A is less than equal to B or A is greater than equal to B will always be reflexive for all AB belonging to the given set A. Okay, so next proceed further with some more interesting examples. So what other examples they may put you, that for a set, suppose another example of a reflexive relation is, if I give you the set A, the set of triangles, and if I say that the relation between the two triangles, say T1 and T2 is such that T1 is congruent to T2. I hope this symbol is you already knows about it, that T1 is congruent to T2. That is what I want to say, that for the set of triangles you want to check that whether this congruency relation is reflexive, right? So what you learned about congruency, can you say a triangle is congruent to itself? Have you ever heard about it? So think about it. Yes, any triangle can be congruent to itself. So what you may say, for reflexive relation, any triangle can be congruent to itself, right? Congruent to itself. So this relation is reflexive. This relation is reflexive. How it is reflexive? Because you may easily see that any triangle can be congruent to itself, right? So congruency relation also is one of the example which relation will always predict the reflexive relation, right? Again, if I take the same set, that is the set of triangles, but I will give you the relation between the triangles is that the area of triangle T1 is less than area of triangle T2, right? So can you see that this type of relation is reflexive? So think about it. Certainly you may say no. Why? Because the area of triangle can never be less than the area of triangle to itself. Right? Because what I told you, that for reflexive relation you have to check whether the area of triangle is less than the area of triangle itself, right? For reflexive relation you may quote both the triangles same. So for reflexive relation, how you will write? That for all A belonging to set A does not belongs to R. Why? Reason is because area of triangle can never be less than itself, right? So what you will say, that for the area is less than to itself can never be an reflexive relation. So this type of relation will not be reflexive. So in your textbooks, many of the examples are there in which you may easily check whether the relation is reflexive or not, right? So this is what reflexive relation means, in which whenever you start with any element A, then for all element A belonging to this AA must belongs to R, but other elements may also come. Okay. So see one more example here. On the behalf of this statement, on the behalf of this definition, can you say that the empty relation is reflexive? So certainly you may say no, is not reflexive. Why it is not reflexive? Because if I say the set A containing 2 elements or 3 elements, then the empty relation will not contain any element, right? But what they wrote, that for all elements of A belonging to AA must belongs to R. But here 1 also belongs to A, right? But 1 is not there in R. 2 belongs to A. Even 2 is also not there in R. Right? So this type of relation is not reflexive. So what you conclude, must put note here, that empty relation is not reflexive. Empty relation is not reflexive ever. Okay. So what about the universal relation? For universal relation, what you will say? What universal relation means, that also we discussed earlier, that for a set A containing elements 1, 2, the universal relation will be across A, which will contain the elements 1, 1, 1, 2, 2, 1 and 2, 2. Okay, this I already explained in my previous videos. You may check there also. This is the universal relation. So you can easily see that universal relation will always contain the elements for all A belonging to A. AA belongs to R. Okay, it may contain other elements also, but it must contain these elements as it is a universal relation. So yes, surely it will always be reflexive. So what you note you may put here, that universal relation is always reflexive. Universal relation is always reflexive. Okay, so I hope the idea is clear about reflexivity. So these are some of the examples. Empty relation can never be reflexive. Universal relation will always be reflexive, right? So there is one more topic there, that irreflexive relation. Okay, one topic is reflexive relation and another type is irreflexive relation. So what irreflexive relation means? Generally the students think about that the relation which is not reflexive is irreflexive. So this is certainly not so. This is incorrect. Why? Because what irreflexive relation means, for irreflexive relation, for all A belonging to A, AA does not belong to R. Right? AA does not belong to R. Only then this relation will be irreflexive. So if you will say that the relation which is not reflexive is irreflexive, so it will certainly no. Okay, it will not be there, because for irreflexive relation the definition is, for all A belonging to A, AA does not belong to R. So what it means, that for a set A containing elements 1, 2, if I will take the relation R 1, 2 and 2, 1, then this will be irreflexive. this relation will be irreflexive. Why? Because 1 1 and 2 2 is not there. Neither 1 1 belongs to R nor 2 2 belongs to R. So this is irreflexive. But it is it reflexive? Reflexive के लिए you will put no. This is not reflexive, but is it irreflexive? So yes, it is irreflexive, right? But sometimes the function, the relation is reflexive. Then can you say that it is irreflexive? So let us check. If I say this relation, right, for the set containing same elements 1, 2, is this relation reflexive? So for reflexive, you may put yes, this relation is reflexive. Okay, is this relation irreflexive? So you may say no. Why this is irreflexive? Because for irreflexive, AA does not belong to R, and for reflexive, AA must belongs to R, right? So it may happen that the relation is reflexive and it is not irreflexive, or it may happen that the relation is irreflexive but it can be it is not reflexive, right? So must focus on this. For irreflexive relation, AA does not belong to R, and for reflexive relation, AA must belongs to R, right? So I hope the idea is clear about reflexive and irreflexive relations. In my next video, I will clear you the topic symmetric and antisymmetric, and thereafter transitive and antitransitive. So till then, goodbye. Have a nice day.